Hello class and welcome to Math Minutes video lesson number 49. We're going to start learning how to graph absolute value. We've already learned about how to figure out what absolute value is and to solve for unknowns, but now we need to see how those apply to a graph. So turn to page 17 in your notebooks and let's get started. Graphing a function that includes an absolute value is identical to making an XY table that is used to graph a linear equation. The only exception is that you must include negative values for x. So let's see what this looks like. Here is our standard XY table. I should have labeled those. Here's XY. And what can we do? We're going to list values in X, just randomly pick them, and then substitute that in for this value, solve it, and we'll come up with our Y. Our input X to get our output Y. So let's just start with 0, because 0 is always an amazing number to start with. If x is 0, the absolute value of 0 is 0. 0 plus 2 is 2. So let's plot that. 0, so we're not going left or right, and up 2 because it's positive. All right, so let's put a negative. We must include negative values. So why don't we try something like negative 2? Well, the absolute value of negative 2 is 2. 2 plus 2 is 4. So at negative 2 and then up 4. All right. Well, let's try a positive 2. Positive 2, absolute value is 2 plus 2. That is also 4. But this time it's positive 2 and up 4. Okay. Let's try negative 5. Negative 5, the absolute value of that is 5 plus 2 is 7. So when x is negative 5, y is 7. Oops, all the way up there. All right. And what we can see here is we're going to end up with a V shape. So it kind of mirrors. It's going to have a mirror, and it's going to always be a sharp V. So let's take a look at, let's do some more practicing, and then we're going to add some more information to this. But let's take a look again. Here's XY. Let's start with 0 again. Well, 0 plus 3 is 3, and the absolute value of that is 3. So we have 0, 3. Let's try negative 1. Negative 1 plus 3 is 2. Absolute value of 2 is 2. So negative 1, 2. All right, well, let's try something like negative 5. Negative 5 plus 3 is negative 2. The absolute value of negative 2 is 2. Negative 5 and 2. All right, this might be looking a little odd, but let's try negative 3. Negative 3 plus 3 is 0. Absolute value of 0 is 0, so negative 3, 0. Now we're starting to see our V shape. And let's do, how do we know this is the lowest? Well, you can just kind of see. Once we kind of get a symmetrical mirror image of a V, we're pretty much sure that that is going to be where it, but let's test it. What if we thought maybe we're not sure, where this line is going to end. So here's our points, and then we had let's try negative 4 to see, because we tried negative 5. Let's try negative 4. We had negative 5, 2. Let's just see if it goes down one more. So let's try negative 4. Negative 4 plus 3 is negative 1, and the absolute value of that is 1. So we would have negative 4, but a positive 1. So there, if you need to do a few more, If you need to do a few more to really be sure where the bottom of that v is, you can go ahead and substitute in a few more different values for x. Okay, let's take a look at number 2. This one's a little bit different because it has a 2 in front of it. And so we're going to see how that affects our absolute value graph. So here we are. Let's pick, let's put our x and y up here. And let's start with 0. And so let's substitute in the 0. So we would end up with 2, 0 minus 1 times the absolute value of 0 minus 1. So 2 times absolute value of negative 1, that equals 1. So 2 times 1 is 2. 0, 2. Okay, let's find, let's go ahead and let's try 2. Well, let's see. This time we have y equals 2 times, and let's substitute our x as 2 minus 1. So we get 2 times the absolute value of 1, which is, again is 2 times 1, which is 2. Okay, this might be looking a little bit odd. 2. Okay. Well, here I might start thinking maybe I've made an error because I'm getting a straight line, but so let's find out what happens in between. So let's pick the value 1 for x. Let's do that. So let's put a 1 in there. So 2 times the absolute value of 1 minus 1 is 0. 2 times 0 is 0. Okay, so now this looks like we're getting somewhere. So that means when x is 1, y is 0. All right, well, let's test something over here. Let's test negative 2. Let's see where that's going to go. Negative 2. So x now is negative 2. 2 times the absolute value of negative 2 minus 1 is negative 3. The absolute value of negative 3 is 3. So 2 times 3 is 6. So we're going to put a 6 here. So that gives us when x is negative 2, y is 6. Okay, and now we can see, let's make sure that we've found the bottom of our v. So let's test 3. Let's see what's going to happen along this line. So let's put 3 in there. So if x is 3, we're going to get 2 times 3 minus 1 is 2. So we end up with 2 times 2 is 4. So when x is 3, oops, there it is. Okay, so if we take a look at this, all right, so if we take a look at, God, I have so screwed this one up. I'm so sorry. All right, here we go. Let's take a look at this. We have made our v. Okay, now can you see what's happened between this v and this v? This one on the bottom is squished a little tighter together. That's what this has done. That's what this multiplier in our formula, this has changed how wide or narrow the v is. Okay, let's take another look at how we can graph these without using an XY table. Because as you can see, that last one I did, it's like, oh, I'm trying to figure out these numbers and how do I know? The first two I picked looked like it was a straight line. So there's actually an easier way to interpret an absolute value equation onto a graph. And here's what this looks like. If we want to graph an absolute value without using the table, it can be done if we understand this form. This form will translate or move the lines. So we always start with our parent function, which is y equals x. So I will use a little xy table on this to illustrate how this happens. How is this a parent function? This is where we start with. Y equals x. If I pick 0, y is going to equal 0. If I pick 1, y will equal 1. If I pick negative 1, y will also equal 1. If I pick negative 2, y will equal 2. So, and I can pick a positive number. What if it's 4? It'll be 4. What this means is we always end up with just a single slope, a positive slope, and a negative slope. So this is our starting point at 0 with a slope of 1, because you can see 1, 1 is right here, negative 1, 1, negative 2, 2. You can see that all these points, 4, 4, all of these points are going to end up on this graph with its vertex. That's a word we haven't used yet, but right there at the origin. So this is where we start. Now, when we look at this formula, we're going to take that parent shape and it's going to get moved. You can see now this one, its vertex is not sitting on the origin. So let's take a look at what this means. So the h in the formula, this is the h. The h in the formula is the horizontal shift. H is the horizontal shift. K is the vertical shift. The absolute value would translate or move 3 to the right and up 4. Because let's rewrite our formula from up here down here. It's y equals a absolute value of x minus h plus k. So if you look at what happened here, here's our h. H is the horizontal shift. So if this parent function, the vertex, started here, horizontal is left or right. It's positive 3, so we went to the right, 3. And then here is our k. K is the vertical shift, and that was a plus 4, so we went up 4. 1, 2, 3, 4. That gives us our vertex, and because the a, there isn't an a here, or there really is, but it's just a 1, that means we have a 1 slope, positive and negative. So let's do some practicing on how we can shift or translate an absolute value problem. So let's write our formula again so we can take a look at it, and it helps us to remember it. X minus h plus k. Now I'm going to make a note of something here and explain this. Let's go back. If you go back to the previous page, and let me erase my markings here. I said that this 3 was a positive 3, and we've always been taught to keep the sign in front of it, that it should have been a negative 3, but here's why it's not. Our formula, let me write it larger. The portion of our formula that says x minus h, the minus is part of the formula. So we are minusing h. H in this case is a positive number. If h were negative, it would have looked like that. And we know that a minus and a minus becomes a positive. Now, I can explain this with a few more examples in class. That's a quick overview, but let me just make a note of how you can remember this without, if you don't understand the minus, minus, plus, minusing thing, okay? Basically, what you're going to do is let's go back to the next page. What you're going to do is you're going to look at that minus h, and you're gonna move, it's gonna be the opposite of what it is. So let's take a look. Okay, I'm so confused. Let's go back to this one. If we have a minus 3, it just means we're gonna do the opposite, which means it would have been a +3. Let's move on. All right, this one, according to our formula, x minus h. There is no h. So what does that mean? There is no horizontal move. So that means we are going to be somewhere, it's going to be 0. We're not moving to the left or right. Now let's look at the -2 is our vertical shift. And because this time we're not going to do the opposite. If this says it's a -2, believe it. It means we're going to go down 2. That means the vertex, we didn't go left or right, we went down 2. There is no A in front of this. That means we know that our V is going to have a positive slope of 1 and a negative slope of 1. Let's do a little testing. Let's do a little practicing here. Let's put x to be 0. 0 minus 2 is -2. 0, -2. There's our vertex. Let's put in a value of 2. Well, the absolute value of 2 is 2. 2 minus 2 is 0. So when x is 2, y is 0. And you can see how this is falling on that line. Well, let's do -2 because one of our rules is we have to use both positive and negative values for x. So if x is -2, absolute value of -2 is 2. 2 minus 2 is 0. So this time we went -2, 0. All right, let's just try, let's do 5. Well, absolute value of 5 is 5. 5 minus 2 is 3. So let's see, x is 5. 1, 2, 3. And there it is, falling on that line. So we didn't have to do the table. We just did that to show you that these are falling on the line. What we did was we followed the rules of the opposite of horizontal and then the vertical shift. So let's try that with the second one. Now, this time we're going to talk about this little negative that's in front of it. When the negative is in front of it, what that means is this graph is going to point down. Our vertex is going to be up and it's going to point down because we have flipped it to the opposite. So let's see what this looks like. So our horizontal shift is going to be what? -1. We're going to do the opposite. So instead of here, our vertical shift, or sorry, our horizontal shift is going to be left, -1. Now, it is not going up or down because it's really like +0, so it's going to stay on the x-axis, but everything's going to point down, and because there's only a negative in front, it's like a -1, we are still going to have just a single slope. It's going to be a positive slope and a negative slope, but it's pointing down. So let's do a few points and find out how this is working. Let's make x 0. 0 plus 1, opposite of 0 plus 1. What is the absolute value of 0 plus 1 is 1. Absolute value of 1 is 1, but now we're taking the opposite of that, so we get -1. So when x is 0, y is -1. So there we go. You can see how it fell on that line. Let's take a number like -4. So let's substitute that in. So now our x is -4. -4 plus 1 is -3. The absolute value of -3 is 3. And because this negative is on the outside of that, our answer is -3. So let's take a look on our graph. We had -4 for x, and we went down 3. 1, 2, 3, and there it is, right there on our line. Let's do one more. Let's pick the value 5. Okay, 5 plus 1 is 6. Absolute value of 6 is 6, and here again, it becomes opposite. So when x is 5, y is, negative 6. 1, 2, 3, 4, 5, 6. And you can see how that lines up. All right, let's take a look at the last one. Now we have combination of things. Let's talk about what is this graph going to look like without doing anything on my XY table. I can tell you I pretty much know what this is going to look like. I know that because there's no H, it's not going to shift horizontally. I know that it's going to go up 3. So it's going to stay on the 0. It's going to go up 3. And now I see that there's a 2 in front of this. I know that the slope is going to be 2. Up 2 over 1, up 2 over 1. And it's going to have the mirror on it. My graph should look like this. Let's test a few and see what happens. Let's make x 0. 2 times the absolute value of 0 is 0, plus 3 is 3. 0, 3. You can see I found my vertex correctly. Let's do another value for x. Let's make our value for x 2. So I'm going to substitute that in. Absolute value of 2 is 2. 2 times 2 is 4. 4 plus 3 is 7. So here we go. 2. And let's follow that up to 7. Voila. Right there. You can see how that point, I didn't have to do any math. I just had to interpret the formula and apply it to the graph. Well, what's our rule is we have to find a negative number. So let's do negative 3. We have to use a negative. So let's make that negative 3. What is the absolute value of negative 3? That's 3. 2 times 3 is 6. 6 plus 3 is 9. So when I have negative 3 for x, 1, 2, 3, and y is going to be 9. I'm going to follow this up. There's 7, 8, 9. There you go. Of course, I didn't use a ruler, but you can see how that's lining up. Well, that is how you do some graphing with absolute value. You can use an XY table to put in values, or you can simply become familiar with the formula and be able to interpret those letters into what's going to, how that little V shape is going to move, how narrow or wide it's going to be, and whether it's going to be pointing down or pointing up. So good luck with your homework, and I will see you in class.